Hello, Year 11. I'm going to go over the solutions for questions 1 to 3 of mock paper 2. For this first question, there's a charge of 5p for a carrier bag, and it was introduced in 2011. So the period we're looking at is 2011 to the 31st of January 2015. And estimated that a total of between 16.8 million and 21.9 million was donated to charity. Okay, calculate an estimate of how much per month. So the first thing you need to do is work out how many months there are. So for 2011, there's 3, because you've got your October, November, December. 2012, you've got your full 12 months. 2013, 12 months. 2014, 12 months. 2015, just the one, because it's to the end of January. So that would be 40 months. So when they want an estimate of how much they've gained in charity, okay, you've got your 16.8 million, you've got your 21.9 million, and if you take a mean value of the two of them, you've got 19.35 million. That's the mean, okay? So if you did it for 16.8 divided by 40, you'll end up with 0.42 million. If you did it for the 21.9 divided by 40, you'll end up with 0.55 million. And if you took an estimate of the mean, if you found the mean, divide by 40, you'll end up with 0.48 million. Now, whichever way you decided to do it, any of these were acceptable. But as you can see, I've shown all the working out, okay? And it is one of those OCW questions where you've got to explain everything. So with this, you took the lowest value. This one, you took the highest amount. And this one, you took the mean. So you'd have to make sure you explained what you did. For part B, over time, there have been a reduction in the use of 5p carrier bags. Okay, what impact might this have had on the amount given to charity for the month of September 2014 compared with September 2012? You would expect more money given to charity in 2014 compared with 2012. By 2012, people were better prepared using their own bags. So anything along those lines. But this question here is to do with speed, distance and time. Rodri goes by car, Megan cycles, okay? But it's the information that follows that that's important. Let's go back to the speed, distance, time triangle. So if we're looking at Rodri's journey, we know that the distance is 5.5 and the average speed is 22. So what we don't know is the time. So time is 5.5 divided by 22, which is 0.25 of an hour or a quarter of an hour. But it's worth remembering that that's 15 minutes. We'll see why in a minute. For Megan, we know that the speed, so I'm just going to put the speed in here, is 12 miles per hour. Now, she arrives 5 minutes before Rodri. So 15 minutes, if you take away 5 minutes, that's 10 minutes, okay? So my thinking now is here, 10 minutes. But we need to change it into hours because of the speed being in miles per hour. So it's 10 over 60 or 1/6 of an hour. So that's going to be 1/6. So when you're working out the distance that Megan travelled, it'll be 12 times 1/6, which is 2 miles. Which is what they wanted. In this question, the distance is 231 kilometres and the time is 3 hours 30 minutes. Okay, because they want the speed in kilometres per hour, you've got to change that to 3.5 hours, or even better, 3.5 hours. So the average speed, distance, time. So the average speed is 231 divided by 3.5, which is 66 kilometers per hour. But what's important is that it's one of the answers in the list. So if you end up with something totally different, chances are it'll be linked in with the time there. You need to check that. Okay, in this question here, cross section of the wedge, you've got horizontal length, you've got vertical height. Now I'm just looking at the triangle and I'm thinking Pythagoras because there's 90 degrees and I know two of the lengths, I'm finding the third. So using Pythagoras, 12 squared plus 3 squared is x squared. 144 plus 9 is x squared. So x squared is 153. X will be the square root of 153. So x is going to be 12.4 centimetres to 3 significant figures. For 3a, the angle y must be less than 15 degrees if the wedge is going to fit under the door. So if you go back to the diagram, that's 12, that's 3, that's angle y. Now, whenever you've got a right angle triangle and you're working out an angle, you're going to be using trigonometry. So is it going to be the SO, the car, or the tower? Well, it's going to be the tower because we know the opposite and the adjacent. We don't need anything to do with the hypotenuse. So you can eliminate those straight away. So the tan of y is opposite over adjacent. So the tan of y is 3 over 12. So to get y on its own, the angle is the shift tan 3 over 12, which you can use on your fraction button. And the answer is 14.0 degrees to 1 decimal place. If you go back to the question, show that the wedge will fit under Yared's door. Yes, it fits. Because it is less than 15 degrees. Yared decides to make a larger wedge that is mathematically similar to the one shown in part A. The wedge is to have a vertical height of 4.5. Right, the original diagram, the 12 and the 3, if it's similar, then there's a connection between the 3 and the 4.5. You're comparing both vertical heights. So how did 3 become 4.5? Well, the length scale factor is 4.5 divided by 3, which is 1.5. So the new horizontal length is going to be 1.5 times bigger than 12. If just to clarify, the 3 to the 4.5 is times 1.5, and you've got to do 12 times 1.5. 12 times 1 is 12.5 of it, which is 18 centimetres. Thank you. Hello, Year 11. I'm going to go over questions 4 to 6 from the Numeracy mock paper 2. Okay, a lot of information here to do with the grass racetrack. This is the region shaded in the diagram. Each end of the grass racetrack is created from semicircles, the inner semicircle having a radius of 15, the outer semicircle having a radius of 20. So the first thing you notice is because that's 15 there and all of that is 20, then the grass part is 5 meters. Each of the straight sections of the racetrack has a length of 65, and it's showing you the straight parts are 65, which would be the same at the top as well. Okay, what is the total area of grass in the two straight sections? Now, what I did was I focused on that rectangle there and the rectangle here. So, just to clarify, 65 and 5, but you've got a second one which is opposite. Okay, so 65 times 5 is 325, but you've got two parts of it, which is 650 meters squared. So what we just worked out are the shaded parts, straight part areas. Okay. Right, calculate the area of the grass racetrack. Without the picture from the other page, you've got to appreciate, I'm going to see now if I can show you here, these were the straight parts, but you've also got the two outer parts which are made up of semicircles. Now, visually, I'm hoping you can appreciate that that is the same as the two straight parts, but these two parts will fit together almost like a donut. I'm trying to do it visually so that hopefully you can see what it is. Now, the large circle area will be pi times 20 squared. Okay, the inside part of it is pi, the inside circle is pi times 15 squared. So the shaded part will be the pi times 20 squared, take away the pi times 15 squared, and you'll end up with 549.78 meters squared. But then you've got to add on the two areas. So you've got to add on the 650. So you end up with 1199.78 meters squared. Okay. So that's, go back to the question, you've worked at the area of all of the grass track. Right, the grass is to be treated with a fertiliser. It costs 20 pence to treat each 3 meters squared of grass. Okay, so working with the value that we just had, 1199.78 meters squared, for every 3 meters squared, it costs 20 pence. So you'd have to see how many threes are in that value and then times by 20 pence. So the calculation, if you want your answer in pounds, because it says to the nearest pound, you would have to do 1199.78 divided by 3 times 0.2, and you'll end up with £79.99. But to the nearest pound is definitely £80. Okay, now the message here is, if you didn't get part B correct, okay, this was the answer that we got, you follow through with whatever answer you've got, okay? So you obviously wouldn't get the full marks, but whatever you got from part B, okay, work with it in order to get your answer. Okay, right, now with this question, I'm really glad that they've put into this central bit the key information, because it's very confusing because there are so many letters, okay? But it's obviously to do with hot water and cylinders. Plumbing engineer wants to calculate how long a shower can be used continuously before the water runs cold. He uses the following formula. Okay, so this part of the formula. Right, Daisy cylinder holds 300 litres of water, so there's some key information there, there's some more key information. So it's a case of picking out what we need. So after all of that, this is where it tells you what to do. Use the formula to calculate the additional volume of water that feeds into Daisy's cylinder. Now this here is what we're trying to work out. And as it happens, there is a formula for C. So if we're picking out the formula that we need, the H x minus m over the m minus y. So H is the volume of hot water in the cylinder, which is 300. How do I know that? Because it tells me there. Then your X value is the temperature of the water in the cylinder, which is 60, because it tells you there. Take away M. M is the temperature of water in the shower. And the temperature of the water in the shower is set at 32. All over, the M value is the temperature in the shower, which is the 32, because it's been set at that. And your Y value is the temperature of cold water that feeds into the cylinder, which is the 8. So put that all into the calculator and you will get 350 litres. So that's the first part. The number of minutes Daisy shower will run continuously before the water runs cold. Now, it's this part, and again, we've got a formula. And usually, if they give you two formulas, chances are you might have to use both of them. So if T is equal to C plus H over F, now, again, you work with the C value that you've got to follow through this value. Because if you check, we've just worked out C. So that's 350. Your H value is 300. Okay, it's the same as the H value there. Okay, and then it's all over F. Now F is to do with the rate of flow, which is your 26. Now when you work that out, it'll be 25 minutes. Okay. Question 6a. Dr. Khan and her daughter Farrell have different opinions about the mean temperature in their hallway. Dr. Khan and Farrell recorded the temperature in the hallway at 4 p.m. each day during the 30 days of April. Now that's quite significant, 30 days of April, because in a notepad, Dr. Khan summarised the temperatures in a group frequency table. Unfortunately, part of it has been torn off. So because you've got the 8 and the 4, that's 20, which means that that must be 10 days. So certainly the total number of days is 30, because there are 30 days in April, and it actually tells you in the question. Okay, so because we're working out an estimate of the mean, you need mid value times frequency. So for the first one, you will have 20.5 times 4, you'll have 21.5 times 8, you'll have 22.5 times 8, and then 23.5 times 10. That's 82, that's 172, 180, and then 235. That gives you 669. Okay, now an estimate of the mean, is going to be the 669 divided by the 30, which is 22.3 degrees. And it's always worth checking. You should end up with an answer which is between the range of numbers in the table. you've got something like bigger than 24, less than 20, then you've gone wrong somewhere. Okay, for part B, what assumption have you made in calculating an estimate of the mean temperature at 4 p.m? Well, we've used the mid value. Use the mid value. Again, it's only worth 1 mark. We've used the mid value to represent the group. Okay, part C, Farrell recorded the same temperatures as her mother at 4 p.m. each day during April. She found that the actual mean temperature in the hallway during April was lower than the correctly calculated estimate of the mean. Explain how this can be true. Now, this might be because the temperature may have been near the lower end of the groups. We took the mid value, but it might have been that it was measured lower. Okay, so that kind of explanation, or many were lower than the midpoint. Shouldn't need much thinking if it's only worth 1 mark.